In this video, we'll learn how to use Excel to perform the hypothesis testing for the mean when sigma or the population standard deviation is not given. We have to use the t-test in this case. T-test is a statistical test for the mean of a population, and we use this when the population is normally distributed or approximately normally distributed and the population standard deviation sigma is unknown, it's not given. Excel does not have a procedure unless we use the XLStat or the MegaStat add-in to conduct a hypothesis test automatically for a single population mean, but we can apply the formulas manually to find the p-value. And if the p-value is less than alpha, which is the significant level, then we will reject the null hypothesis. So let's take a look at the two procedures we have here. First, we need to find the test statistic t. It is equal to the x bar minus the mu naught divided by s over the square root of n. X bar is the sample mean, mu naught is the population mean, and it is taken from the claim and used in the null hypothesis h naught. And s is just a sample standard deviation, and n is just the sample size. To find the p-value by finding the area of the left tail, the right tail, or the two tails of the t-distribution curve using the function t dot dist. This is the t-distribution, t dot dist, and this function takes in three inputs: x, df, and cumulative. X is just the value of the test statistics, the one that we have here on the t-axis. df is the degree of freedom n minus 1. Cumulative, if we put true, the function will give you the area on the left of that x value. And if we put false, then it will return the probability density function at x. Okay, let's look at this figure. This is minus t, the left tail. So we want to find the p-value, which is the area under the curve. So we apply the t dot dist. This is the function that will return the area under the curve on the left side of whatever you put here. In this case, negative t. And then the next one is the degree of freedom n minus 1. And we put true because we want all the area on the left side. To find the right area, the right tail, we have to find the area on the left tail and then subtract that from 1, because 1 is the whole curve, and 1 subtract the area on the left, which is the white area, will give you the area on the right, because there's no direct function to find the area on the right. So we have to borrow the area on the left of this value and just subtract that from 1. And for the two-tailed case, we just need to find the area for one of them, and then we multiply by 2 because they are symmetric. And again, for the rule, if p-value is less than or equal to alpha, we reject the null hypothesis. If p-value is bigger than alpha, we do not reject the null hypothesis. Okay, let's take a look at this example. Consider the given below information. Test the hypothesis using the p-value method. The mean is equal to 4,000, and the claim is saying that the mean should be bigger than 4,000. So because this is bigger than, or the arrow is pointing to the right, we know this is the right tail case. And we are also given alpha 0.01, the x bar, this is a sample mean, 4,014. The sample standard deviation is 20 for small s and 25 for n, assuming that the data comes from a normally distributed population. And on Excel, we can use direct functions to find the sample mean x bar, and we can always use the stdev.s to find the sample standard deviation small s here, if the problem does not give you this value. And if you have the list of the value, then you can use these two functions to find the required x bar and the s. And now we can compute the test statistic using the formula x bar minus the mu naught divided by s over the square root of n. X bar is the sample mean, which is given here. Mu naught, this is the one that we assume to be true, 4,000. And then s is 20 over the square root of n is 25. And this is 3.5. And the degree of freedom is n minus 1. We have 25 for n. So n minus 25 minus 1 is 24. Remember, this is the right tail test. So we expect to find the area on the right side of the test statistic. In this case, 3.5. 0 is always in the center. So 3.5 is to the right of 0. And I'm looking for the right tail. So I'm looking for the area on the right. So to find the area on the right, you can find the area on the left and then subtract 1 to that, right? So if I go here, I want to find the left area of 3.5. Well, the reason I want to find the left area is because we do have a function that gives you only the left area of that value. They don't have the area, the function to give you the right area, but they have the function to give you the left area. So the left area of 3.5, which is the one on the left side, 3.5. Once you get that value, we take 1, which is everything, subtract the left side to get you the right side. So we press equal. We use, this is a t distribution because we don't know the population standard deviation. So this is going to be t dot dist. Okay, so the first argument would be the x. The x is 3.5 because I'm looking for the value at that point. The degree of freedom, we have 25, so 25 minus 1 is 24. And cumulative, I type true because I want the left area of 3.5. I hit enter. This is my left area of 3.5. So my p-value, and that is simply just the area on the right side of 3.5. And I just take 1, which is everything, minus the area on the left side. And it will give me 0.00092 or 921. And that is my p-value, the area on the right side. And this one is really small. Of course, this is less than alpha. So we reject the null hypothesis. So we reject the null hypothesis because the p-value is really small and it's less than alpha.